Welcome to another requested work solution, and we're going to be looking at question 1 from the May 2014 Time Zone 1 paper 1. Okay, and we're looking specifically at matrices. All right, so work out when possible each of the following. If it is not possible, write not possible in the answer space. Well, let's just go through these matrices that we've got up here and write down their orders before we even get started so we can decide whether or not they're possible or not. So remember, the big thing when we're talking about matrices is row by column. All right, so the order of this particular one here is we've got 2 rows and we've got 2 columns. So this is a 2 by 2 matrix. Here we have 1 row and 2 columns. So this is a 1 by 2 matrix. And here we have 2 rows and 1 column. So this is a 2 by 1 matrix. And here we have another 2 by 2. Okay, so work out when possible each of the following. All right, 2A. Can we work out 2A? Of course, we can work out the scalar multiple of any of our matrices. Okay, so this is A. So if we're going to be doing 2A, all right, we're just going to multiply all of the elements within that matrix by 2. So 2A is going to be 6, 4, minus 2, and 2. There's 2A. It's just the scalar multiple of matrix A. Okay? B plus C. So we're going to try and add B and C. Now, when we're adding matrices, they need to be the exact same order. Now, we could multiply these two matrices because when we put their orders together, the 2 middle numbers are the same, but we cannot add them. If we're going to add them, they need to be the exact same order. So we're going to say not possible. Not possible. All right. And AD. So AD, we're going to try and multiply A by D. All right. So we've got AD. All right. So A and D. Can we multiply them? Yes, we can. Okay, we've got a 2 by 2 and a 2 by 2. If we put those orders together, that's 2 and 2. Because they're the same, we can definitely multiply them. And then the resultant matrix, the order is also going to be a 2 by 2. We can see that by the outside numbers there. So AD is just going to be, AD will be 3, 2, minus 1, 1. And we're going to multiply that by 2, 0, 0, 2. Okay? So, again, it's row by column. We always have to remember row by column. So we're going to multiply this row here by the first column there. So we've got the top row, left-hand side. So that's going to be the element on the top left-hand side. Okay? The element on the top left-hand side. So we're going to have 3 by 2, 3 by 2, plus, so 3 times 2, plus 2 times 0. 2 times 0. So that's our top left side. Now if we're going to do the top right side, that's going to be our top right element here. We're going to have 3 by 0 plus 2 by 2. 2 by 2. All right. So we've done the top left and the top right. Okay. Let's look at the bottom. Let's go for a different flavour here while we do this. we're going to do the bottom row, okay, by the left column. All right, so minus 1 times 2, minus 1 times 2, plus 1 times 0, 1 times 0. And then we'll do the bottom row, multiply, so bottom row, we're on the bottom row here, multiplied by the second column, the right-hand side column there. So it's going to be minus 1 times 0, plus 1 times 2. 1 times 2. And now if we just simplify that, we're going to get 2 3s are 6, 2 2s are 4, and negative 1 times 2 will be negative 2, and 1 times 2 will be 2. So I'm just checking. Yeah, I've got a 2 by 2 matrix. That should be my resultant, and we're happy days. Okay, let's keep going. Now we need to find A inverse. Okay, A to the power of negative 1. That's the inverse of A. All right, now first of all, I'm going to write down A over here. So I've got A is 3, 2, negative 1, 1. All right, that's our A over here. All right, and I've got to find the inverse. Now, before I find the inverse, I need to find the determinant. All right, the determinant of A. So A, and I'm going to use these absolute value brackets here. So the determinant of A is going to be 3 times 1, 3 times 1, all right, minus 2 times negative 1, minus 2 times negative 1. All right, so that's our determinant, and if we solve for that, our determinant is going to be 3 times 1 is 4, minus 2 times minus 1, minus minus 2, which will be positive 5. Okay, so that's our determinant. All right, we have the determinant. Now all we need to do is we're going to take 1 over the determinant, 1 over the determinant, so 1 over 5. All right, and to find the inverse, I'm going to swap these two elements. So the first diagonal, I'll swap those elements, 1, 3, and then with these two elements, I'm just going to swap their signs, like change their signs. So I'm going to make this a positive and this one a negative. All right, so that's going to be positive 1, and that will now be negative 2. And here we have the inverse of A. I might just highlight that so you can see it. So the inverse of A is equal to 1 over the determinant, and then there we go. Remember, we just swapped these two elements and then we changed the signs of these two elements here. Okay. All right. Let's have a look at our final question here. Why is it not possible to work out CD? All right, let's go up and look at CD. So CD. Now, it's not possible to work out CD because of their orders. See these two numbers here? So this is a 1 and a 2. We've got ordered side by side. These orders need to be the same, okay? And so they are not compatible, all right? If these two numbers were the same, they would be compatible. So we can do B and C can be multiplied because the orders, these two numbers in the middle are the same. These are not, A and B are not compatible, but we know from before that A and D are compatible. So the answer is, explain, orders or order not compatible. All right. Okay. Describe fully the single transformation represented by the matrix D. Okay, so matrix D. Matrix D is this. Let me just double check here what order we are. Here is 2 0 2 0. 2 0 0 2. This is matrix D. Now, far from remembering all of the different transformations, okay, what we can do is we can actually test the transformation of a point or 2 points, okay? So let's draw a little set of coordinates here, okay, and we'll have 1, 2, 3, that's up here, we'll have 1, 2, 3, okay, and let's just pick an easy coordinate. Let's pick 1, 1, all right, and we'll see what happens to 1, 1. So let's multiply this by 1, 1, okay, and see how we go. Actually, well, let's pick 2 points. We'll pick 1, 1, and we'll pick 2, 1. So we've got 1, 1, and 2, 1. So we've got 1, 1, this being our x coordinate, this being our y coordinate, and we've got 2, 1. Okay. So let's just do that. And we're going to go, all right, that will be equal to, all right, row by column, so 2 times 1 plus 0 times 1 is going to be, this will be 2, 2 times 2, that'll be 4, okay, and then row by column, 2 times 2, that'll be 2, and then 2 times 1 will also be 2. So if we multiply that out, we end up with our new coordinates. So what's happened here, we've got 2, 2. So let's use a different colour here. We've got 2, 2, so 2, 2 here, and then we've got 4, 2. So if we go out here, 1, 2, 4, 2. So actually what's happened here is we've got an enlargement. We can see that these are twice the distance away from the origin. We can see that they're twice the distance away from each other. So this is what you would call an enlargement. Enlargement. And it's a factor of 2, because all these are double. Factor 2. All right. Thank you for listening and watching. And if you have any questions or whatever, or anything you need clarified, please comment down below. And we'll see you in the next video.